So in this particular problem, we have to show that the derivative of y with respect to x is given by sine inverse of x over 1 minus x squared raised to the power of 3 over 2 when y is given by this particular expression. So let's begin with y. So we will rewrite y before performing the derivative. So we have y equals to x times sine inverse of x. So what we'll do, we'll take the expression square root of 1 minus x squared from the denominator to the numerator. So that means we need to multiply it to 1 minus x squared all raised to the power of negative half plus natural log of, so here we have 1 minus x squared raised to the power of half. If we apply the property that log of a raised to the power of b, so that's equals to b times log of a. So what we can do, we can rewrite this as half and we can get rid of this half from here. Now we will differentiate both sides with respect to x. So we have derivative of y with respect to x, that's equals to derivative of this particular expression. So what we will do, we'll treat x as the first function and sine inverse of x times 1 minus x squared raised to the power of negative half, this as the second function. So applying the product rule, we have derivative of the first function with respect to x times simply the second function, which is sine inverse of x times 1 minus x squared raised to the power of negative half plus x times derivative of the second function plus half. Now we need to take the derivative of log of 1 minus x squared. So we know that derivative of the logarithmic function is simply 1 over x. So that means this will be 1 over 1 minus x squared. But then again, we need to apply the chain rule. So this will be multiplied to the derivative of 1 minus x squared. Let's further simplify. So we have derivative of y with respect to x. So derivative of x with respect to x, so that's 1. So that means we have sine inverse of x times 1 minus x squared raised to the power of negative half plus x times. So now we again have to apply the product rule. So let's treat x sine inverse of x as the first function and 1 minus x squared raised to the power of negative half as the second function. So we have derivative of the first function, which is sine inverse of x, and that's simply multiplied to 1 minus x squared raised to the power of negative half plus we have sine inverse of x times derivative of 1 minus x squared whole raised to the power of negative half plus we have half times 1 over 1 minus x squared derivative of 1 minus x squared, so that will be negative 2x. We can cancel out the 2 and further simplify to get, we have sine inverse x. So let's take this term to the denominator. So this will be simply square root of 1 minus x squared plus x times. So we have derivative of the inverse sine function, which is given by 1 divided by square root of 1 minus x squared times. So we'll take this to the denominator as well. So this will be 1 over square root of 1 minus x squared plus sine inverse of x times. So here we have to take derivative of 1 minus x squared raised to the power of half. So we'll use the power rule. So that is negative half times 1 minus x squared raised to the power of, so we have negative half minus 1, so that will be negative 3 over 2 times, apply the chain rule, so take the derivative of 1 minus x squared, so that will be negative 2x. Then we have negative plus negative x over 1 minus x squared. Right. So this is dy over dx. So we have sine inverse of x divided by square root of 1 minus x squared plus, so this will be 1 over 1 minus x squared and we have to multiply with x. So this will become x divided by 1 minus x squared plus, so we have x times sine inverse of x. Now here, this negative 2 and this negative 2 goes away, and this x gets multiplied to give us x squared. And then we have to multiply this with this term. We'll write it in the denominator. That will be simply 1 minus x squared raised to the power of 3 over 2. And the final term, negative x over 1 minus x squared. Luckily, this term and this term goes away. So we are left with two terms. Now let's take the, let's combine these two terms. So this will be dy over dx 1 minus x squared raised to the power of 3 over 2 as the common multiple for both the two denominator. So in the numerator, we'll have 1 minus x squared multiplied to sine inverse of x plus x squared times sine inverse of x. So this will be simply sine inverse of x minus x squared times sine inverse of x plus x squared times sine inverse of x, whole thing divided by 1 minus x squared raised to the power of 3 over 2. So this goes away. So we have our final expression for dy over dx. So we get dy over dx, that's equals to sine inverse of x, whole thing divided by 1 minus x squared whole raised to the power of 3 over 2. So this is what we are asked to prove. dy over dx equals to sine inverse of x divided by 1 minus x squared. Yeah, so this is correct. Thank you.